Yes, hi, ladies and gentlemen. My name is Jean a chemistry teacher at College de Ruhanga. Now we are going to see all chemical properties, yes, of organic compounds. Yes, in senior 5 is prepared by and presented by me, Jean as you see. Start with alkane. The question: why boiling point of alkane is greater is increased? Yes, increase as a molecular increase. The solution is that as is due to magnetic of van der Waals forces. Yes, this as the channel alkenic is a very important increase. Yes, I think that I have seen. The reason is this. Also, example, this from 1 carbon to 4 carbon. Yes, are gas. From carbon 5 to carbon 17, it is a liquid. From this 18 to above are solid. It means that as the chain, as the molecular mass increase, also the boiling point increase. It means that you have gas, you have a liquid, you have a solid. Yes, if you have a gas, yes, you have a gas. Yes, gas has yes, lower melting point than liquid, and liquid has a lower melting point than solid. It means that solid has a higher, yes, boiling point. I think you understand. And why straight chain alkane has more boiling point than branched alkane? Example, here we have a straight alkane, which is have this boiling point, and this is a branched, which is have this boiling point, and which is tertiary, means that more branches has this temperature, means that as branch, the more branched, yes, less boiling point. I think why because in the why because it is due to closer packed in a straight alkane. Yes, in a straight alkane, straight yes, there are closer packed, yes, but here there is scattered. You understand? Alkane are non-soluble in water because has a low polarity. Yes, yes, no hydrogen bond form, but it is soluble in non-polar solvent like this carbon tetrachloride, this carbon sulfide, and in benzene. Also are miscible with another. Yes, with another means that it makes, yes, it mix with another. Means that like dissolve like. Chemical properties. Carbon to hydrogen covalent bond. This carbon hydrogen has the same electronegativity, means that it is slightly polarized, means that here this carbon and this here it forms stronger. Yes, bond don't break easier. Carbon and hydrogen have near same electronegativity values, hence yes, carbon hydrogen only slight polarized. Generally, carbon is considered as covalent bond. They have an share electron to offer. This is the property of alkane. Alkane. Of alkane, they are going to start with the alkyne. You understand? For alkane, it is double bond. It means that the boiling point of alkane is less than alkane. Boiling point of alkane increases as molecular mass increases. Yes. From carbon 1 to carbon 4, it is a gas at ordinary temperature. From carbon 5 to carbon 18, it is a liquid, and also above it is a solid. It means that as molecular mass increases, molecular mass increases, also the boiling point, yes, boiling point increases, yes, increases. You see. Also here, alkane are soluble in water, are insoluble in water, but soluble in most organic. Also, since has a greater, yes, has a yes, has high boiling point than trans. The why? The reason is this. Uh, yes, high boiling point. Yes, since alkane have a slightly high boiling point than trans alkane because dipole moment is in the trans structure cancel each other. Yes, means that dipole in yes in trans yes cancel each other. Yes, cancel each other. I think you understand. Means that we have this Atlans. We are going to draw the Atlans. Remember, we have a double bond. Then you remember Atlas. Yes, I think we are going to draw. Yes, Atlas. In Atlas, yes, in trans, this hydrogen can be cancelled with this also, and also this metal can be cancelled with this one. Means that yes, this trans has yes lower melting point due to the anti-cancelling. Yes, urabona ngaha izi hydrogens zikwiye kugenda igasimplify ikaba simplify with ni metal ikaba simplify with the ngi igasigara nta attachment ifite, niyo mpamvu ifite lower boiling point ugereranyije na trans ugereranyije na cis. Yes, thank you. Sorry to say in Kinyarwanda. The chemical property of alkane is more reactive than alkane due to double bond. Also can be undergo additional reaction due to the electron can be attacked this double bond due to the high charge density region in this hydrogen in this double bond. Yes, example unstable. Yes, unsaturated alkane can form saturated saturated. Example alkane by electrophile attack on this carbon. How? We are going to see. Electrophile is electron deficient or Lewis acid or electron pair accept how the double bond in alkane is region with higher density electron. Therefore, this region is hereditary by electrophile. An electrophile is an atom or molecule of or an ion which is electron deficient Lewis or electron pair. I think that I have explained here. How this electrophilic addition yes can be okay. It can be okay in two-step. Yes, two-step. Step one, formation of carbocation. Here, this electrophile can be attacked. This, I mean, this bond can be broken down with this one. Then there is here there is A. There is a carbocation plus this bromine. I mean this ions. These ions I'm going to attack on this on this on this. Yes, after this ion, yes, we'll attack on this one. I mean, this is the second step. But here, this is the first step. This is the first step. You understand? Yes, this is the first step. First step. Let us continue. Two steps of electronic, yes, electrophilic addition. The first is, I think that I have explained where. This is the first one is the formation of carbocation. The second one is, yes, reaction of carbocation. Yes. The result are this one. Finally, remember here we have A. Finally, we will have this. We have this carbon with finally this B will attack on this. We have this A and also B. This is the final one. You understand? Markovnikov rule, yes, state that when this carbocation occur, yes, this electrophilic addition, there is a respected the Markovnikov rules, where this hydrogen will go on in the this is the Markovnikov's rule states that hydrogen halide on a symmetric alkane the reaction lead to formation of two products in two steps. First, there's a formation of two different carbocation with major product and from more stable, which is more stable, major product is more stable. This is Markovnikov rule. This is the electrophile addition of an asymmetrical reagent to an asymmetrical double bond proceed by, yes, involving most stable carbocation. We are going to see. The example here, I will have this one. By respecting Markovnikov rule, here we have this product, two product, major and minor. In this major, it is more stable because it is this cation is on the middle, whereas this cation is on the rest, yes, carbon means that is unstable. Yes, by using Markovnikov rule, Markovnikov states that hydrogen is added to the carbon with more hydrogen substitute, is that to form more product. Example, here this hydrogen will go to this one, here to this carbon that has, yes, that has two hydrogen. Example, it form this one, yes. But here hydrogen will go in the carbon that has less hydrogen to form mine. Yes, result to this chlorine. Aha ni ukuvuga ngo zino product haraho izi electrophile ni attack barakoresha harifashishwa Markovnikov rule yavuze ko hydrogen ziyongera kuri carbon ifite hydrogen nyinshi. Urabona nk'i carbon hano ifite hydrogen ebyiri, ariko ingi ifite hydrogen. Ukoresha Markovnikov rule, hydrogen iraza kwihuza, iraza kujya kuri carbon ifite hydrogen nyinshi, biforming iyi major product ariho urabona aha ngaha at the last hari eshatu, none hano hagahita hasigara plus ya chlorine ikaza guhita ijya kwataka kuri ya plus. Naho ahangaha minor iraba anti-Markovnikov, anti ngute iyi hydrogen yaza kujya ahantu hari less, iyi carbon ifite less, hydrogen ifite hydrogen imwe, ariko ingi ifite ebyiri. Ubwo rero iraza kujya ku izi ngizi zifite imwe, aro biraza gufominga ahangaha, ahangaha zigahita ziza kuba ebyiri, ya chlorine ikajya kuri on the last. This is the, yes, the minor and, yes, major and minor by Markovnikov and anti-Markovnikov rule. Here, this is the anti-Markovnikov rule. This is, mine is formed by anti-Markovnikov rule. Yes, we understand. So to say in Kinyarwanda, is stable carbocation among this method, this primary carbocation, secondary carbocation, and tertiary. Example, the method, yes, this is more stable. This is this is tertiary is more stable. Yes, this is more stable than this and than this and than this. I think this is the order of stability. Methyl is less stable than primary, less stable than secondary, less stable than tertiary. Means that increasing of order of stability. Yes. If they ask you a question among this one, select which is more stable. I think that the more stable is one. This is more stable. This is less stable. Yes. Alkane. We are going to start alkyne. Yeah, thank you. Alkyne has a triple bond, you know. Yes, example, alkyne has a triple bond, you know. A triple bond, which is, yes. Yes, with angle, with this angle, yes. Yes, they are non-polar like ethane with the same molecular, yes, mass. Also, yes, is insoluble, are insoluble in water but dissolve each other and non-polar solvent. Yes, additional reaction. This alkane undergo to, yes, unsaturated hydrocarbon alkene are very reactive than alkane because they are unsaturated alkane undergo reaction. Alkene can undergo to more reagent. I'm going to see each by one. Even if they have high electron density than alkane, means that this has electron density than alkane. They are in generally less reactive because the triple bond is shorter and therefore the electron cloud is less accessible. How we are going to see it. Alkyne undergo two steps. One step, this there is a removal of this triple bond to form this one, and this ion. Then the second, this bromine is attack on this carbocation, but to form this one. Here, yes, we have the double. We have a double bond. We are going to remove this double bond. It means that it undergo another an electrophic addition. We are going to add this one to remove this bond. There is yes, there is a Markovnikov law, aho hydrogen yajya kuri carbon ifite hydrogen nyinshi, ahangaha ubwo ahangaha zahita ziba eshatu, hano hahita hasigara plus bromine ize kuyataka. Yes, aribyo hano byatanze results. Ni ukuvuga ahangaha kuri alkene kugira zina bonde eshatu zishiremo. Yes, kuri alkane, for alkane, kuri alkane yo alkane, sorry, yes, kuri alkane example. Yes, urabona ko yes irakora step imwe, irakora step imwe. Yes, niba hajyaho hydrogen bromine, yes, birahita biba step imwe kuko ifite double bond. Ariko kuri alkyne kuko hari bond eshatu, bwa mbere yes irakora ntuza, yes irakora electrophic attack. Yes, noneho isigarane double bond. Iyi double bond n'ubundi yongere ikore ifate electrophilic addition, tubone ariyo final product ariyo iyi ngiyi. Yes, niyo mpamvu ahangaha kuri alkyne tuvuga ko ikora 2 steps arizo twagerageje gusobanura. Yes, I think you understand. You get something. I think you get something. Yes, you understand. Yeah, we have yes, we have this. Thank you. Alkene. We are going to see alkyl halide. Property of alkyl halide. Yes, this is a very important increase as size increase. It means that here this we are going to consider iodine has a greater size than bromine. Means that as size increase, yes, the very important increase. Yes, here we have an example. This alkyl are the same. Yes, these alkyl are the same. These alkyls are the same, are common. But we are going to consider this halogen. Ahangaha alkyl turabona ko ari zimwe, turakonsidaringa zino halogen gusa. Uko size yongera ni nako yes, boiling point yongera due to the magnetic of van der forces increase it. Yes, I think that I have explained where this all the same. Also the density, the boiling point, then the density increase as size increase, you see. Also solubility of halogen can therefore dissolve more than alkane, and only slightly soluble in water. Yes, in water means that halogen can dissolve more than alkane. Yes, in water. You understand? Yes, we have also seen the boiling point, density, yes, and solubility. Means that if you have alkyl halide, yes, alkyl halide, yes, this is more soluble than alkane. You understand? Alkane. A bit of alcohol. Your lower member of alcohol are completely soluble in water. Means that yes, because a mixed hydrogen bond between water and mercury are formed. Yes, as the length of carbon increase, solubility increase as chain. Yes, chain increase. It means as the length of hydrocarbon group alcohol increase, the solubility. Yes, solubility decrease. Sorry here. This is a mistake. Solubility decrease. Yes. Yes, solubility decrease. What about volatility? Volatility is how to evaporate. Alcohol are volatile. The volatility decrease as molecular. Yes, means that you have a volatility. Volatility decrease. Yes, as molecular mass increase. You understand? Compared to alkyl halide, yes, compared to alkyl halide, alcohol are less volatile. Means that we have example. We have alkyl halide. Yes, we have alkyl halide example. This one. Yes, it is greater than alcohol in volatility. The comparison between, yes, volatility of alcohol and alkyl halide has, yes, this is the volatility. Means that alcohol, yes, has less is less volatile. Yes, is less volatile. Yes, is less volatile than alkyl. You understand? This is the alkyl. This is the alcohol. You understand? Thank you. Of alcohol, then start of ether. Ether, yes, you know there is no hydrogen bond in ether, you know. Also, ether is primarily soluble in water, but other are soluble in organic solvent. Yes, due to electronegativity, the result intermolecular force is the polar interaction. It is a polar in nature. Yes, you know it is a polar in nature. Yes, you know, yes, if it is one, means that it is a negative. It is partially positive, means that this is a polar. Yes, this is a polar molecule. A polar. Also, ether can form. Yes, the polar. Yes, I think I have covered. An ether can't form hydrogen bond. Yes, no hydrogen bond. Yes, no hydrogen bond in ether. Cannot form hydrogen bond. Means that it has a lower boiling point compared to, yes, alcohol. The melting point, yes. The melting point increases as the molecular mass, yes, increases due to, means that if you have a boiling point of ether increase, yes, as the molecular mass increase due to, yes, due to the magnetic, yes, due to magnetic over forces will, yes, force with size as the increase. The boiling point ether are lower than alcohol, similar molecular mass. This is because the molecular hydrogen bond which are present in alcohol are not possible in ether. Example, this is the examples. The boiling point is this. For alcohol, the boiling point are this. Yes, this is the same. The molecular mass are the same, but the boiling point are the same. It means that hydrogen has high due to hydrogen bond. Here there is a negative due to no hydrogen bond present. Yes. Also, this alcohol has a high boiling point compared to this one due to hydrogen bond. Start of carbonyl. Thank you. Carbonyl, yes, alcohol has a hydrogen bond compared to, yes, carbonyl, no hydrogen bond. It means that alcohol has a high boiling point than alcohol. Also, carbonyl form hydrogen bond when react with, yes, water. Alcohol has a higher, yes, boiling point than ketone. Similarly, in alcohol there is hydrogen bonding. Yes, in ketone there is no hydrogen bonding. Either than ketone are polar molecules, but alkyne are non-polar molecules. Yes. Pay attention. Also, those carbonyl can form hydrogen bond with water, but also this alcohol has inside the hydrogen bond intermolecular forces. This is intramolecular forces. Example, this is hydrogen bond. This is the water, but this is a carbonyl. Yes, a carbonyl compound. This is carbonyl compound. Yes, twavuze ko muri carbonyl nta ubwayo muri yo nta ntuza nta hydrogen bond igira ugereranyije na alcohol. Igira hydrogen bond igihe yahuye n'amazi. Alcohol ubwayo alcohol ebyiri zishoboye kugira hydrogen bond ubwayo. Yes. Polarity of this carbonyl and alkane. Carbonyl has a, yes, high polarity than alkane. Why? This is a charge positive and charge negative. Remember this oxygen has high electronegativity, means that it has a high polarity than alkane. Yes, you see. Polarity, yes. And I think that I have summarized I have already said, yes. Yes, during chemical reaction, nucleophile will attack the carbon functional group, which is Ba positive. Example, here we are going to add this nucleophile. Example, nucleophile. Yes, nucleophile, yes, or hydroxide will attack on this one. Yes, example, yes, hydroxide, example, hydroxide or chloride, yes, will attack on this one. Backside, this is a backside. While electrophile will attack oxygen, whereas electrophile will attack, yes, will attack, yes, will attack, this, will attack those, yes, electrophile will attack oxygen, will attack oxygen, yes, while electrophile will attack oxygen, yes, which is Ba negative, yes. Carbonyl, start of carboxylic acid. Acid also, what about acidity? We have something inductive effect. What is it inductive effect? Example, we have this one. Urabona ko iyi ngiyi ifite ntuza, ifiteho methyl, ifiteho methyl, ahangaha ifiteho methyl zingahe? Eshatu, iyi ngiyi ifiteho methyl ebyiri. Yes, mu izi ngizi urabona ko iyi ngiyi bavuga ko ifite inductive effect, iri weak, iri less, yes. The greater number of such group, the greater effect, and therefore the weaker will the acid. Iyi ni ntuza ni iyi ni weak acid. Yes, iyi ni weak acid, iyi ngiyi ni strong acid. Kubera ko alkyl group zino halides zifatiyeho ari nyinshi, ariko ahangaha ni nyinshi. Uko zibaho zikurura hano ari nyinshi, urabona nkahangaha kwino ntuza, yes, urabona ko hari imbaraga ziri ku alkyl group iri kujya ikurura ahangaha, itanga ahangaha. Urabona uko zirafatiraho nyinshi niko zirayigabanyiriza imbaraga. Bigaragare ko iyi ngiyi irimo acidic, yes, irimo acidic ugereranyije n'iki n'iyi ngiyi. Ubwo iyi ngiyi iri weak acid. You understand? Yes. This is what you say inductive effect. Yes, inductive effect. This is a weak acid. This is a stronger acid due to less alkyl group. Kuko ifite amantuza make, yes, sorry. Iyi ngiyi ifite amalkyl menshi, yes, this is have more alkyl, this one and this one, it is a weak, yes, it is a weak, yes, not this one. This is a weak. It is a weak acid. It is a weak acid due to more alkyl. Yes, due to other group, yes, more other group. Yes, this is strong acid due to other group, yes, is less. Yes, you understand? The greater number of such group, the greater effect. Therefore, the weak will acid. Example, this 2,2-dimethylpropanoic acid, this one is a weaker than 2-propanoic acid, which is 10 weaker than propanoic. Yes, this is a weaker. I think I have already explained. So, when you have a negative inductive effect, urabona ko ahangaho hafatiyeho noneho chlorine. Ntabwo ari methyl. Urabona iyi ngiyi ifiteho chloride. Iyi chloride ifite high electronegativity. Birasaba rero ko iyo irakurura, niza gukurura, yes, inductive effect garagazwa n'iki? Na fresh. Yes. Therefore, due to this, yes, this is inductive effect. Also here there is inductive effect in this one. There is inductive effect in this one. Also here there is inductive effect, and here, and yes. there is inductive effect. Due to this negative, which is high electronegativity, it causes this to be more acidic. This is a more acidic than this one. This is a yes. On the other hand, when electron withdraw group with negative inductive effect, it is present. The opposite thing observed. Yes. For example, chloroethanic is stronger than chloracid, ethanoic acid. It means that this is a chloroethanoic acid. This is this one. This is a stronger acid. Yes, due to chlorine which has high electronegativity. Here we have this is a weak acid. You understand? Yes, ahangaha bashoboye kuguhereza yes. Zino yes acid uko arebye bakakubaza niyo iri weak and niyo iri strong and why. Ni kuko ifata iyo ni chlorine cyangwa halogen zifite high electronegativity, niyo mpamvu ishoboye kuba iri strong acid kuko dissociation yayo yaba iri completely. Ahangaha dissociation in water yaba iri partially, you know. Yes. You know, this chlorine is being electronegative, more electronegative. More negative inductive effect, more acidic, means that more negative inductive, more acidic, I think. This nimba kuri iyo alkyl group hafatiyeho fluorine niza iri more acidic ugereranyije ni chlorine ugereranyije ni hydrogen. Yes, you understand. Yeah, this is example trifluoroacetic acid is more acidic than trichloroacidic, than dichloroacetic, than chloroacetic, than acetic acid, because fluorine is more electronegative than chlorine and than hydrogen. Yes, you understand. You get something, I think. Yes, if you have hydrogen, means that if you have this fluorine with, yes, example this alkyl halide, yes, we have also chlorine with this Ala, and also you have bromine with this Ala. This Ala is stand by, yes, this acidic, yes, means that this is more acid than this is a more acidic than this one, than this. Why? Because fluorine is more, yes, acidic, yes. Yes, fluorine is more, yes, has a high electronegativity, yes, than others. You know, this has a high electronegativity than this and than this. Also, this is the boiling point, yes, of carboxylic acid and alkane. Example, this carboxylic acid is this one. This is for carboxylic, the boiling point as a molecular mass increases, the boiling point increases. You see, this is for alkane. As for alkane, the more branched, yes, melting point decreases. You see, for this alkane, this is the boiling point is this one. For this, as means that this is the high. Yes, it is negative. Dimeric of carboxylic or dimer. This is the one carboxylic. There is this hydrogen bond. Also, this other this acid they form this dimer. Yes, dimer hydrogen. Carboxylic have high melting point because of hydrogen bond enhance possibility of bringing two acids together to form kind of dimer hydrogen bonding. You see, dimeric structure of carboxylic acid. Yes. About solubility, yes, the solubility decrease as chain increase. Yes, you understand. For carboxylic acid, yes, solubility, yes, decrease. Yes, as chain, yes, as chain, yes, as chain increase. Yes, hydrogen, yes, also hydrocarbon chain is insoluble in water. Yes, hexanoic is slightly soluble in water. Parametric, yes, is larger and non-polar hydrocarbon part is essentially insoluble in water. Carboxylic is generally soluble in organic solvent. Yes, generally, yes, soluble in organic solvent, such as ethanol, toluene, and the ethyl ether. This is the organic solvent. Means that carboxylic is soluble, yes. Then start of ester has this ester boiling point of ester is less than alcohol and carboxylic acid. Why? Because there is no hydrogen bond in, yes, there are hydrogen bond in ester. Yes, no hydrogen bond. Also, the ester has a sweet fluid smell. Yes, molecular mass has increased, the boiling point increase. As yes, I think also ester are very soluble in water. Yes. Also solubility decrease as length increase. Sorry here. Yes, solubility. Yes, not like this. Solubility here it is decrease as chain increase. Yes, end of ester start amide. Yes, molecular mass increase as boiling point increase. Means that boiling point increase as molecular mass increase. Means that amide has yes high boiling point. This is a boiling point. Yes, this is a boiling point. It has a high boiling point than ester, and amide yes has a hydrogen bond. Yes, amide has a hydrogen bond. So also here this is the hydrogen bond in amide hydrogen bond caused to have yes high boiling point except this one. Formaldehyde no hydrogen bond, but all other crystal solid at room temperature amide have high boiling point and melting point than ester due to hydrogen bond presented as shown here. This is one amide, this is another amide, there is a hydrogen bond. Start of nitrate. Nitrate is high soluble in water, colorless solid, other high polar. Yes, I think here there is a summary. I think there is also solubility decrease as molecular mass increase. Here the high soluble in water, but solubility decrease with increase of mass as non-polar part become larger. Yes, it is high polar. I think I have and electronegativity. Yes, it is a form dipole moment because this positive, this one, this is a positive, this is a negative, this is a positive, this is a polar, form polar, yes. Yes, the form polar, that is a positive, that is a negative. End of nitrate, start of amine. Amine has a lower boiling point due to no hydrogen bond. Yes. Primary and secondary amine can form hydrogen bond to each other as shown in the figure, this one in the student book below, yes. Because nitrogen is less electronegativity than oxygen, means that this alcohol has high hydrogen bond than this amine. This hydrogen and this is not quite as polar as this one because the reason why amine are not strong as alcohol. Yes, here this amine, yes, oxygen, here oxygen has high electronegativity compared to this amine. Yes, you understand? Here we have this amine. Also here we have, yes, oxygen. Due to this one, this is has a less, yes, has a less, yes, hydrogen, yes, the hydrogen bond is weak due to this is has high electronegativity compared to this nitrogen. Yes, you understand? You get something means that nitrogen has less electronegativity than yes electronegativity. electronegativity than, yes, than oxygen. Also, this is the hydrogen tertiary, yes, tertiary amine, no hydrogen present, means that tertiary amine don't form, yes, each other by hydrogen bond, no hydrogen bond, they have a boiling point similar to, yes, hydrocarbon, also alkane, due to no hydrogen bond, yes. However, primary and secondary and tertiary amine form hydrogen bond with water, yes, with water to form hydrogen bond. Yeah, with water, this is the water. Yes, with the water, yes, to form hydrogen bond. For all, this is a primary, secondary, and tertiary. All they form hydrogen bond. Yes, with lower molecular weight, generally soluble in water. Yes, this is a generally soluble in water. About its solubility, it is a soluble. Solubility, yes, decrease as molecular mass increase and boiling point increase. General boiling point of amine increase as the molecular weight increase, high temperature than alkane, but lower temperature than alcohol of compared to molecular mass. The amine is soluble in organic solvent and solubility decrease as molecular mass increase. I think that I have summarized here. End of physical, yes, properties of organic compound in senior 5. Thank you, dear brothers and sisters. God bless you to all.